So the story continues with Niels Bohr. Niels Bohr in 1913 picked up the baton, if you like, from Rutherford. He was invited by Rutherford to Cambridge University because he was an outstanding scientist. He was creative and a highly intelligent man, and he was very interested in the work of the German scientist Max Planck, who had some various ideas about energy and something called quanta, which are like packets of energy. And Niels Bohr proposed that because of the experiments he was doing on the elements and seeing the various lights and colours given out by different elements when they're put in a Bunsen burner flame, he proposed that what happens is when elements absorb energy, the electrons get excited and move to a higher energy state. And then when the electrons drop back down to a lower energy level, they emit a packet of energy which corresponds to a wavelength of light. And that's why we see the colors of various elements really clearly, like lithium is this vibrant red color, and magnesium is white. Copper is sort of a bluey green, and sodium is like an orange yellow color. And often these are used in fireworks. Now, he proposed that electrons occupy energy levels, or what we call shells, and that's where we get the GCSE model of the atom from, the Bohr model of the atom, with 2 electrons on the first shell, 8 on the second, and 8 on the third. His work was then followed up by Henry Moseley, who, I'll keep this fairly short, but basically fired X-rays at atoms and looked at how they were reflected off and diffracted off. And from that, he worked out the atomic number of the periodic table. So that's where we get the atomic numbers from. And it finally finishes up in 1932 with James Chadwick, who discovers the neutron, which puts that inside the nucleus of the atom. And that then explains why the nucleus of the atom is where all the mass is, all the mass from the protons and the neutrons. So, in summary, here's a little timeline. We've got the original John Dalton model of the atom that we can see on the far left, proposed in 1807, the solid spherical sphere that Berzelius sort of improved upon. And then we move into the end of the 19th century, beginning of the 20th century, with the plum pudding model proposed by J.J. Thomson, with the electrons embedded in a positively charged atom that made the atom overall neutral, and then followed up by Ernest Rutherford with his famous gold foil experiment carried out by his 2 research students, Hans Geiger and Ernest Marsden, and proposing the nuclear model of the atom, where you've got this tiny, tiny, tiny nucleus where all the mass is and the positive charge surrounded by these electrons, and then further improved by Niels Bohr to put the electrons in shells. So we've finally got our model of the atom today, and additionally on the bottom there you can see the discovery of the subatomic particles in order for you to see as well. Now, in terms of GCSE questions, things that come up quite often, the plum pudding model comes up, Ernest Rutherford's model comes up, and how Ernest Rutherford's model and his gold foil experiment disproved, or improved I should say, the plum pudding model. On the foundation tier, also, and the beginning of the higher tier questions, we often get the 3 subatomic particles coming up. You can see the electron, proton, and neutron. You have to know about their properties, the order of their discovery. Okay, so we're now going to do, I'm going to now test your knowledge on this a little bit more. But thank you very much for listening.